both be in the same place here. Okay. So as you can see, this project has two different classes, a book class, which I created. It has a title, author, and ISBN property, and then a car class, which only has a make and model property for now. And then you can see here that I've already created two instances of car and one instance of book. So we'll be able to start typing our code here in about line 17 or 18. But again, back to the example. Suppose that I want to work with all of these cars collectively and put them in essentially and group them together in a collection or an array. I probably will wind up using a collection because of the reasons that I said earlier. It gives me so many additional options here. So what I want to do is start off by talking about a specific type of collection called an array list. And I want to start by talking about it because it's a lot like an array, but it has some added features that are pretty nice. For example, array lists are dynamically sized, so you don't have to say ahead of time how large you want your array to be. You can also add and remove items really easily using some methods. And the other thing about this particular collection is that it'll allow you to put any data type into it. You don't have to specify that it's a specific type, whether string or integer or car. Of course, that's the downside as well. So let's go ahead and get started by creating a new instance of this array list. So I'm going to go dim my array list as new system.collections.array list. All right, now obviously I used its full name. Apparently I didn't need to because it's already been added to the default collection of namespaces. So I can just hit Control period on my keyboard and I can choose the simplify name and just go ahead and remove that. And now we're working with the array list without the full name. All right. So now what I may want to do is go my array list dot add car1 and my array list dot add car2. And then what I can do also is do a for each for each item as car in my array list, and I can do console.writeLine and do item dot, and I can print out either the make or the model. Since it's strongly typed and I know what kind it is, I can say, hey, just print out the make for both of the cars in the array list. All right, and you can see that I get the list here. Now, one of the dangerous things about the array list is that it is so flexible. So what we could do with the array list is actually add that instance of book that I created, or actually it's just B1 is the name of it. I can add that to my array list as well. And when I run the application, I'm going to get an invalid cast exception. In other words, you can't convert a book to a car. So on the third iteration through, I try to take the book and say, this is actually a car, and it says, no, it's not, and it won't let me proceed. All right, so I can easily break my application. Let me see if I can do something here and just remove that, and now I'll try to run the application again. Now I get a different exception. I said, let's not call this a car. Let's just make it an object so that it passes that test, and we're not going to check whether it's a car or something else. However, when I attempted to access the make property of the book, well, there is no make property of the book. And so I get a different exception, missing member exception. So I guess the moral of the story is that the bad news is you can add anything you want to the array list. It's very accepting, which is both good and bad. Now the good news is that I can honestly remove an item as easily as I can add an item to my array by using the remove method, and now the application works again because we both added but then removed that item from the array list. Okay, so I just wanted to show you what's possible. Now I already noted some downsides about the array list. while it is extremely useful and flexible and probably better than an array, the fact that you can put anything inside of it's kind of a problem. So what we want to do is actually use two better collections. They're called generic collections. They're generic because you have to define the type for the collection to make it specific. So let me go ahead and just type in some code and then I'll explain how this works. We'll use a list of T generic collection. So here we go. Dim my list as list of car equals a new list of car. My list dot add car1. My list add car2. And now we can do a for each in my list. Okay, so this is going to require a little explanation. Let me just make sure it works, and it does. What is this list of car? Well, its formal name is list of T, where T represents a data type, any data type that you want to make it specialized. So in other words, it's a generic collection, but we're making the generic collection specific by saying it can only be a list of cars and nothing else. So you'll remember that I was able to break my application at runtime, but it passed at compile time by adding a book, B1. But this time, we're going to get an error whenever we try to add the book to our generic collection, our list of car, because value of type book cannot be converted to car. All right, so it's better to catch these things while we're doing our software development. And by using a generic list, in this case, a list of car, we're narrowly defining the collection and saying it can only work with cars, so don't try to add anything else to it. Generally speaking, whenever you're working with data in software development, being very restrictive is better than being unrestrictive. Now, some people would disagree with that and say, for example, JavaScript allows you to be very dynamic, but then again, a lot of people shoot themselves in the foot with JavaScript. Whereas with C#, you're going to get those compilation errors ahead of time if you are putting those restrictions on your types up front, okay? And that's what we're doing here. So now let me show you one more type of collection. Generic collection is called a dictionary. And think about a dictionary that you're familiar with, like Webster's dictionary. You have a word that you need a definition for, so you go and you turn the pages until you find the word, and then next to the word is usually a sentence or a paragraph that explain or is associated with that word, okay? And that's the idea of a dictionary. The same thing is true here. You're going to have a collection that'll have a key. In this case, you know, in the case of the Webster's dictionary, the key would be the term that we're looking up, and then the value would be the definition itself, which would be the sentence or paragraph explaining the key. So we can create that same sort of situation by creating a dictionary. So here we'll go dim my dictionary as new dictionary of car. Whoops, I got to give it two things. I have to give it, first of all, T key and then T value. So the type of the key. And so in this case, I'm going to use a string as the key, and then I'm going to give the type of the value, which will be a car. So we're going to give our dictionary, whenever we create a new item in our dictionary, we're going to give it two things. First of all, we'll give it the key, which will be the car, so car1.make, and then we'll give it the actual car1 itself. So now we can find any item, any car in our list of cars by merely using the make. So here we'll go mydictionary.add car2.make, and then car 2. All right. And so let's go ahead and go console.writeLine, and let's look up my dictionary, and we'll look up I think, what do we have here? We have the geo prism. Okay, so we'll look up the geo, and then we can get to its make or its model, like so. All right, so I can index into the dictionary by supplying the make, which is the key to get a specific instance of the entire object. All right, so let's go ahead and run the application, and you can see that now we find that the prism is the model because geo is the make. All right, very cool. Now we can attempt to go my dictionary dot add, and we can go ahead and give it b1 dot author as a key, and then attempt to give it the book itself as the actual object that it'll be saving in the dictionary. However, we're going to get an error. The value of type book cannot be converted to car. So while author is a string and it would probably pass, unfortunately, or fortunately rather, the book is not of type car and it cannot be added. So it's restrictive, and that's a good thing because we catch those kind of problems while we're writing our code. Very nice. Okay, so moving on from there, we've got two generic collections we can work with, the list of T and the dictionary of T key, T value. Let's talk about object and collection initializers. So did you remember from before where we did this? Dim names as string equal to, and then I gave it, I think, Eddie and Alex and David Lee and Michael. All right, and then we were able to now, in one line of code, both create and initialize our array. Well, you can do the same thing with objects and with collections of objects. So here we'll create a new car. So let's do this. Dim my car as new car. All right. And then I can use the with keyword, and I can just do this. Dot make equals, let's make this a BMW, and then dot model equals 745 Li. Okay. Now I've created a new instance of the car object and populated its properties, all without the use of a constructor like we did previously when we were looking at creating constructor methods. I'm able to create an object and initialize it all in one line of code. Looks very similar to what we did with arrays, right? Very cool. All right, and then to kind of top it all off, I can use the same kind of process to create many instances of car and add them all to a new list of car, all in one line of code. Even though it'll be separated on different lines, it's essentially one instruction that we're passing into Visual Basic. So here we go. Dim my list of cars as new list of car. All right, so that's the first part. Now we're going to use the from keyword, from, and then opening and closing curly braces. And I'm going to go ahead and just make some room for myself here and then use my arrow keys to kind of navigate around. New car with, and here we'll go, make equals Aston Martin, and model equals DB9. Then I'm going to use go to the end of that object initializer and go to the next line and create another new car with dot make equals Audi dot model equals the A8 comma new car with dot make equals a dodge, and then dot model equals the dart. Okay. All right, so then at the very end, we'll just go ahead and collapse those last two curly braces. So it can start getting confusing because, you know, what curly brace belongs with what curly brace. But typically what happens is if you select one, you'll see that it's slightly grayed out, and it'll show you its corresponding opening or closing curly brace by giving it a little gray background as well. So whichever one you've got selected, it will show you its corresponding beginning or ending curly brace by highlighting it in light gray color. Okay, but essentially this is one line of code. Now what we can do is we can for each our way through for each item as car in my list of cars. And here we'll go console.write line. We'll just go item.make or model. Actually, we'll do item.model. Let's go ahead and save it and run the application. And you can see there are the three models of cars. And essentially, we were able to, in one line of code, create a new list of car and then create three new car objects and add them in to initialize that collection with new instances of the car object as well, all in one shot. Wow, that's pretty crazy, right? So at any rate, that's all I really wanted to tell you about. Let's recap what we talked about in this lesson. We talked about collections, both generic collections and non-generic collections. We talked about why you want to use a collection, especially a generic collection. Then we talked about the list of T and the dictionary of T key, T value, how to create those, why they're better than just your normal collections, because they enforce types and so they restrict the types that can be used inside of the collection, which means we can catch errors since it's strongly typed at compile time rather at runtime. Then we looked at an object initializer here, and then we looked at a collection initializer here. All right, and next up what we're going to be able to do is use the link extension methods in the link language in order to filter and sort and group our collections. And so that's one of the reasons why you'd want to use collections over arrays when you're working with lots of data. And so we'll do that in the next lesson. We'll see you there. Thanks. Hi, I'm Bob Tabor with Developer University. In this video, we'll learn about LINQ, L-I-N-Q, for filtering, sorting, and performing other group-related functions on collections like we just learned about in the previous lesson. So LINQ stands for Language Integrated Query, and it comes in two forms, and we'll look at both of those in this lesson. There's, first of all, the query syntax itself, which resembles SQL, the structured query language. So if you're already familiar with SQL, you will see some similarities and will help your adoption of LINQ. But there's also, in addition to the query syntax, there's a method syntax. So it's just calling a series of methods just like you would any other method, and you can chain those methods together like we learned about previously. Now the only little wrinkle here is that they use a special feature of Visual Basic called lambda expressions, which are these like mini tiny functions that you pass in as a parameter argument into those methods, and that can sometimes bend your mind a little bit if you're not familiar with looking at them. But we'll take a look at them, and I'll try to explain what each of the little lambda expressions do for us. And I'm only going to show a few examples of LINQ in this lesson. Frankly, you could create a whole course just around using LINQ inside of your applications just to demonstrate all the features of LINQ. So it's a pretty extensive topic. To get started for this lesson and introducing LINQ, I want to grab the source code for this lesson from the before folder, and I'm going to copy that and put it into my projects directory. And we'll paste it there. Great. Now let's open that up, and if you take a moment to catch up with me, you will be looking at the same thing I'm looking at right now. As you can see, I have a car class. It has make, model, year, and sticker price. And then I'm creating a new list of car, creating several cars using that object and collection initializer syntax to create 5 cars so that we can start filtering and sorting these cars and displaying them on screen. Okay, so first of all, let's just take a look at how to do a simple query syntax for to find all of the cars that are from BMW. So let's go dim BMWs equals from car in my cars, which is the name of the collection, as you can see here. Then where car.make equals BMW, select car. Okay. And then here what we'll do is just do a for each item as car in BMWs. And we'll just do console.writeLine. And here we'll just make it easy. We'll go use the replacement syntax and just use item.make, item.model, and item.stickerprice. And we'll go ahead and just format the sticker price. All right, so let's run the application, and we'll see now that we get from our link query only 3 BMWs out of the possible 5 cars on our car lot, and we're also displaying the model and the price. Awesome. Okay, so that's a simple case where we're just looking for and filtering by a single property of the objects inside of our collection. Let's go and make this a little more advanced. In fact, I'm just going to copy the previous example, paste it here, and we're going to say that this is almost identical, but instead of just filtering on one of the properties, I'm going to filter on 2 properties and find those BMWs that were created in the year 2010. All right, so what I want to do is just to add another item here, and we'll go item.year. Okay, and so now let's save it and run it. And we can only find one BMW that is a 2010 model in our list of cars. All right, so by using the AND keyword, we're able to add additional filtering criteria in our link query. All right, so far so good. What if we look for just those newer cars? So let's start off by going dim new cars equals from car in my cars, where the car.year is greater than 2009. Let's just go ahead, first of all, and just select the car itself, and then we'll come back and do this a little bit different the next time through. I'm going to change this from BMW, since we changed the name of the collection we're retrieving back, to new cars. All right. And so let's run the application, and you can see now we get 2 cars back that were newer than 2009. And now let's go one step further and say we only want to select out certain attributes. So instead of select car, let's select just a couple of attributes and put them into a new data type. So car.make and car.model. And those are the only 2 attributes that we're going to use. Now, already you can see that we've got a small issue here. When I added this select new with, it doesn't like it here because I'm no longer working with a collection of cars. I'm working with a collection of something that resembles a car because it has 2 similar properties, but this data type that I'm actually creating here on the fly, it will only have two attributes, a make and a model. In other words, I'm creating a new data type. I'm projecting the data from car into a new data type. What's the name of the data type? I have no idea. We're just making it up as we go along. It has no name. It's anonymous. So we're creating or projecting out only a couple of properties from our query into a new anonymous data type, a class that we're creating on the fly that has no name. Now internally, Visual Basic will give it a name. So that's one of the problems here that we see, that we are, instead of working with a collection of cars, we're working with a collection of something called prime A, the little dash in the A. So all you need to know about this is we're just going to remove this as car part here, and it should work. Now, you'll see that we're going to get some more errors. Why? Because this new anonymous data type doesn't have the idea or any definition for a sticker price or a year. So we're going to need to delete those attributes as well. But now that I've done that, whoops. Okay, we got to also remove the replacement syntax here associated with it, and now we can run this. There we go. So I realize that I threw a lot at you in that little code example, but just reason with me here. If I don't need to pull back all of the data, and because I only want to display just a few properties of the data, then selecting the entire object out of the collection and putting it into a new collection might make that new collection just as large as the old collection. So I can be a little bit more savvy about only choosing those attributes that I really need and putting them into a new anonymous type. Now, you may never do this. I just wanted to show you what was possible. All right, so again, this is called projection, and we're projecting into an anonymous type in this example. But there were some ramifications from it. It was a little more complex, and I don't want to throw you too much, so let's just move on from there. And let's talk about, instead of filtering and projection, let's look at how to order, and this will be a simpler example. So ordered cars equals from car in my cars, order by car.year, and then select car. All right. And so let's just call this ordered cars. And then let's also add back in item.year. And let's go ahead, add back in the as car. And let's go ahead and run it. And so we should see a list of all 5 cars. And let's also add back in the display of the year so we can see that. All right, so now we're going in order from the oldest to the newest. So what if I wanted to actually sort them in the opposite fashion? I can order by descending. There we go. And now when we run it, it will start with the newest cars and go to the oldest cars. Great. All right, so we saw a few examples of the query syntax, and I didn't emphasize it at the time, but if you are familiar with the structural query syntax, things are in a little bit different order. Like, for example, in a structural query language syntax, you would see the select first and not last. However, the syntax is close enough that you can easily adapt your thinking to remember it and fumble your way through with the help of IntelliSense. All right, so let's start back over and remake a few of these examples, except not using the query syntax, but rather the method syntax. So here we go. Let's start with just finding all BMWs. So let's go dim BMWs equals my cars dot. So look, we're already using, instead of, we're using methods instead of using a syntax that looks like SQL. So here's where things get a little funky, right? I'm going to have to find all cars that, what was the criteria again here? That are BMW. Okay, so here what I'm going to do is pass in what's called a lambda expression, which is a mini method or a mini function. So I'm going to say the criteria we're going to use for the where clause is I'm going to create a little function and I'm going to pass in each car in my list of cars. And I want you to pass me